Imagine standing like 3 feet behind this massive 3,600-watt concert subwoofer that is just absolutely pounding out club-level bass, and, well, you hear almost nothing.
Right, this is a complete dead zone.
Exactly. So today, our mission for you is to really do a deep dive into the actual acoustic physics behind how QSC pulled that off with the KS212C Cardioid Subwoofer.
Yeah, we are tearing apart the engineering of this specific piece of gear to see why it represents such a massive leap forward for live sound.
And we're doing it all without getting buried in dense audio jargon. So to start, we really have to look at the problem. Bass is just messy.
Oh, incredibly messy.
Yeah.
Low-frequency sound waves are just huge and slow, and they naturally want to roll out in every direction at once.
I like to think of it like a bare light bulb hanging in the middle of a room. It just radiates energy everywhere.
That's a really great analogy, actually. It blasts the audience, which, is what you want,
great.
but also blasts backward, completely muddying the stage for the band.
Yeah, creating that awful muddy echo bouncing off the back wall. So why did it traditionally take a whole engineering team to stop that bass bleed?
Well, because you had to use brute force, essentially, to break that omnidirectional habit, to force bass into a cardioid pattern, like a heart-shaped pattern.
Right, pushing energy forward and killing it in the back.
Yeah, exactly. Engineers had to haul out multiple subwoofer boxes. They would physically stack them, face some backward, and then use, complex outboard processors to delay the sound coming out of the rear-facing speakers.
Wait, so you're trying to time it perfectly so the sound waves physically crash into each other?
Precisely. It's called phase cancellation. If the peak of a sound wave from the front speaker meets the trough of a wave from the back speaker in midair, they cancel each other out.
But doing that manually has got to be a logistical nightmare.
Oh, totally. It requires advanced math, lots of physical space, and just a ton of trial and error.
Which brings us to the actual box we're looking at today. Because QSC took that entire multi-box array, the delay processors, all that math, and somehow crammed it all into a single 15mm Baltic birch cabinet.
Yeah, you've got a 3,600-watt Class D amplifier driving two 12-inch speakers inside one enclosure.
But wait, if you have two massive drivers pumping air inside one sealed box, how does it not just tear itself apart? Where does that rear energy actually go?
Well, it doesn't really go anywhere. It essentially destroys itself.
Oh, wow. Destroys itself.
Yeah, through what's called a dual sixth-order bandpass design.
Yeah.
So think of the inside of this wooden box, not as a hollow cavity, but as a highly calculated acoustic maze.
Okay, an acoustic maze.
Right. The internal chambers separate those two 12-inch drivers. And the amplifier automatically fires one driver just a fraction of a millisecond differently than the other.
So the box itself is doing all that math.
Exactly.
Yeah.
The sound waves travel through those internal wooden mazes, and by the time they exit the ports at the back of the box, they are perfectly out of phase.
That is wild.
They collide and create a literal vacuum of sound right behind the speaker. The result is a massive negative 15 decibels of sound attenuation from the front to the rear.
And since all that phase cancellation is happening entirely inside the wood, that completely changes how an AV tech physically sets up a room. A mole DJ can just roll in this single 88-pound box, plug it in, and instantly get perfectly aimed bass.
And that physical flexibility is built right into the exterior design too. Because the cardioid pattern is locked in acoustically, you could deploy the unit vertically or horizontally.
Oh, that's really handy.
Yeah, both orientations have threaded M20 pole fittings to easily mount your top speakers. And despite being one manageable unit, it pumps out 132 decibels of peak sound pressure.
Reaching all the way down to a deep 44 hertz.
You got it. It is serious chest-thumping power.
But what good is power if it's just rattling the cocktail glasses at the back bar? How do they keep it from turning into a blunt instrument?
Well, that is where the onboard computing comes in. The rear panel features an LCD screen where users can save and recall variable crossover scenes.
And a crossover basically acts as a traffic cop, telling the high frequencies to go up to the top speakers and the deep rumbles to stay in the sub.
You nailed it. And combined with what QSC calls intrinsic correction, which is built-in software that constantly adjusts the tuning to optimize physical performance, it just sounds dialed in right out of the gate.
So for you listening, if you've ever been to a modestly sized venue, like a wedding or a corporate event, where the sound was perfectly clear and punchy rather than a booming, rumbling mess, gear like this is exactly why.
It really democratizes complex acoustics. For about $2,300, everyday AV professionals are getting that highly controlled, heart-shaped sound precision.
The kind of precision that used to require a massive stadium rig and, an acoustic engineering degree.
Exactly. It's a shortcut to perfect sound.
It really is.
Yeah.
And it leaves you with something to think about. If audio engineers have figured out how to easily shape and direct invisible, unruly bass waves just by fundamentally redesigning the box they come in, what other chaotic elements in our daily environments could be instantly tamed if we just redesign the box?